All right, let's go. Number 10. WASP 76b, the planet where it rains liquid iron every night. There is a planet in the constellation Pisces, approximately 640 light years from Earth, where the weather forecast is not merely inhospitable, it is a category of meteorological violence so far outside anything in the solar system that describing it in terrestrial terms requires repeated recalibration of what the word extreme can actually mean. This planet is called WASP 76b, and on its night side, every single night, without exception, liquid iron falls from the sky. WASP 76b is a hot Jupiter, a gas giant roughly twice the mass of our own Jupiter, orbiting its host star at a distance so close that a full year on this world lasts just 1.8 Earth days. At that distance, the gravitational interaction between the planet and its star has locked it into tidal synchronization, one face permanently baking in the stellar radiation, one face permanently turned away into perpetual darkness. The day side of WASP 76b receives so much stellar energy that its atmospheric temperature reaches approximately 2400 degrees Celsius, hot enough to vaporize iron, which has a boiling point of approximately 2862 degrees Celsius under Earth-like pressures, with the lower atmospheric pressures on a hot Jupiter bringing that threshold even lower. Iron exists on the day side not as a solid, not as a liquid, but as a gas, evaporated directly from whatever iron-bearing compounds exist in the deep atmosphere, and lofted upward by violent convective circulation. The circulation pattern on WASP 76b flows from the scorching day side to the frigid night side, where temperatures plunge to approximately 1500 degrees Celsius, still extraordinarily hot by any solar system standard, but cool enough that the iron vapor condenses, not into iron snow, into liquid iron droplets falling through the upper atmosphere of the planet's night side in a continuous global-scale rain of molten metal. In 2020, the ESP-RSL spectrograph on the Very Large Telescope detected iron vapor in the atmosphere of WASP 76b, present on the evening limb where the day side transitions to night, absent on the morning limb where the night side transitions back to day. The iron is being rained out of the atmosphere on the night side so efficiently that by the time atmospheric circulation carries the gas back around to the day side, it has been depleted. WASP 76b is a planet where iron behaves the way water does on Earth, evaporating on the hot side, precipitating on the cool side, and cycling between these states in a permanent planet-scale meteorological loop made entirely of metal. Number 9. PSR J1719-1438b, a planet made entirely of crystallized diamond orbiting a dead star every 2 hours. In 2011, a team of astronomers using radio telescopes in Australia, the United Kingdom, and Hawaii announced the discovery of a planet so compositionally extraordinary that it immediately strained the boundaries of what planetary science considered physically possible. The planet, designated PSR J1719-1438b, orbits a millisecond pulsar, a neutron star spinning 173 times per second, the collapsed remnant of a once massive star, at a distance so close that a full orbit takes just 2.2 hours. The planet completes more than 10 full orbits around its star in the time it takes Earth to rotate once. The planet's mass is approximately that of Jupiter, but its radius is a mere 40% of Jupiter's, meaning its average density is roughly equivalent to that of platinum, one of the densest naturally occurring elements on Earth. At these densities and under the extreme pressures that would exist in its interior, the material composing the planet cannot be ordinary rocky or icy material. The pressure deep in the interior of such a dense Jupiter mass object would force carbon, if carbon is the dominant compositional element, into its highest pressure crystal structure. That structure is Diamond. The leading model for this planet's origin explains its extraordinary composition as the remnant of a former companion star, a white dwarf that was gradually stripped of its outer hydrogen and helium layers by the neutron star's gravity over billions of years, until only the dense carbon-oxygen core remained. That core, compressed beyond the density of any normal planetary material and crystallized under pressures that no laboratory on Earth can reproduce, is what orbits the pulsar today. PSR 1719-1438b is, in the most literal and physically precise sense of the term, a planet-sized diamond. It is approximately 5 times the size of Earth, composed primarily of crystallized carbon under pressures of hundreds of millions of atmospheres, orbiting a rapidly spinning stellar corpse at a distance closer than many satellites orbit Earth, completing its year in the time it takes a human being to sleep and wake up.
Number 8. GJ121b, the super-Earth wrapped in a global ocean of hot, compressed water that is simultaneously liquid, solid, and supercritical. GJ121b is a world that simultaneously violates and expands the definition of an ocean planet. Located approximately 40 light-years from Earth orbiting a red dwarf star, it was discovered in 2009 and immediately identified as one of the most promising targets for atmospheric characterization, a super-Earth approximately 2.7 times Earth's radius and 6.5 times its mass, with a bulk density so low that it cannot be composed primarily of rock and iron. A significant fraction of its mass must be water or other low-density volatile material. The Hubble Space Telescope's transmission spectroscopy of GJ121b's atmosphere revealed a flat, featureless spectrum, the signature of a high-altitude cloud or haze deg blanketing the planet and obscuring any molecular absorption features from the deeper atmosphere. But what lies beneath that haze, constrained by the planet's mass, radius, and modeled interior structure, is a phase of water that exists nowhere naturally in the solar system, and that requires conditions of temperature and pressure so extreme that the water molecules themselves are forced into configurations with no analog in any ocean on Earth. At the pressures existing deep in the interior of GJ121b, millions to hundreds of millions of times Earth's atmospheric pressure, water transitions through a sequence of exotic high-pressure phases, including Ice 7, Ice 10, and potentially superionic ice, a phase in which the oxygen atoms are locked into a crystalline lattice, while the hydrogen protons flow freely through the structure like a liquid, making the material simultaneously a solid and an ionic conductor. The entire planet may be layered like a compression experiment, a steam atmosphere over a supercritical fluid layer, where the distinction between liquid and gas has ceased to exist, over a deep ocean of hot, compressed water phases that no terrestrial oceanographer has a vocabulary to describe. GJ121b is an ocean world, where the ocean is a state of matter that has no name in any human language developed for the conditions that exist on Earth. Number 7. Kepler-16b, the real Tatooine, a world with 2 suns where shadows always come in pairs. When the Kepler Space Telescope detected the transit signature of a planet crossing in front of its host star in 2011, the initial data suggested something unusual. The transit was not occurring around a single star. It was occurring around a binary star system, 2 stars orbiting each other, with a planet orbiting both of them together in what astronomers call a circumbinary orbit. The planet was designated Kepler-16b, and it became the first confirmed circumbinary planet, the first real-world equivalent of the fictional Tatooine from the Star Wars universe, a planet orbiting 2 suns simultaneously. Kepler-16b is approximately the mass of Saturn, orbiting a pair of stars, one roughly 69% of the Sun's mass and one roughly 20%, at a distance of approximately 104 million kilometers from the center of mass of the stellar pair. From its surface, a hypothetical observer would see 2 stars in the sky simultaneously. their apparent sizes and brightnesses determined by their individual luminosities and the geometry of the planet's orbit. As Kepler-16b moves around its binary host, the angular separation between the two stars changes continuously. Sometimes they appear close together in the sky, sometimes separated by a significant angle, and every object on the surface casts not one shadow, but two, oriented in slightly different directions, overlapping and separating as the relative positions of the two stars shift. The orbital dynamics of Kepler-16b are significantly more complex than those of any planet in the solar system. The gravitational influence of the binary stellar pair produces perturbations in the planet's orbit that cause its orbital plane to precess, the orientation of the orbit slowly rotating over time, producing changes in the geometry of transits observable over decades of monitoring. The planet sits tantalizingly near the outer edge of the habitable zone of the system, though its Saturn-like composition makes it unsuitable for life as we understand it. But the discovery of Kepler-16b fundamentally changed how astronomers think about where planets can form, demonstrating that the gravitational chaos of a binary star system does not prevent planetary formation, and that worlds orbiting two suns are not merely the invention of science fiction writers, but a genuine and potentially common category of planet in a galaxy where binary star systems outnumber single stars.
Number 6, 55 Cancri E. A lava world where the ground itself is an ocean of molten rock, flowing in real time. 55 Cancri E is a planet that makes Venus look like a temperate paradise. Located approximately 41 light-years from Earth, orbiting the star 55 Cancri A, this super-Earth, approximately twice Earth's radius and about 8 times its mass, completes a full orbit in just 17.7 hours, skimming its host star at a distance of approximately 2.4 million kilometers, roughly 25 times closer than Mercury is to our Sun. The resulting surface temperature, even accounting for the planet's likely tidal locking, reaches approximately 2,400 degrees Celsius on the day side, a temperature at which silicate rock, the material composing the mantles and crusts of rocky planets throughout the solar system, does not merely melt, it vaporizes. Observations from the Spitze Space Telescope revealed temperature variations between the day side and night side of 55 Cancri E that were unexpectedly large and variable over time, behavior inconsistent with a simple, tidally locked rocky planet with a static surface. The leading interpretation is that the day side of 55 Cancri E is covered by a global ocean of magma, molten rock several kilometers deep, circulating through convective patterns driven by the enormous temperature gradient between the eternally facing day side and the permanently dark night side. This magma ocean is not a static feature. It is a dynamic, flowing, continuously churning body of liquid rock that behaves oceanographically, with currents, waves, and thermally driven circulation patterns operating on timescales of hours to days. In 2024, JWST observations of 55 Cancri E revealed a thermal emission signature suggesting the planet has a substantial atmosphere, not composed of nitrogen and oxygen like Earth's, but of vaporized rock minerals, silicon monoxide, magnesium, iron vapor, and other compounds that exist as gases only at temperatures exceeding 2,000 degrees Celsius. The atmosphere of 55 Cancri E is, in the most precise sense, the planet itself, rock that has been heated so far beyond its melting and boiling points that it has entered the gas phase and now constitutes the thin mineral vapor envelope surrounding a world whose ground is a churning ocean of fire. Number 5. HATP-7b, the planet where corundum clouds drop ruby and sapphire rain from the sky. The mineral corundum is familiar to most people in two forms. When it contains trace amounts of chromium, it is a ruby. When it contains trace amounts of iron, titanium, or other transition metals, it is a sapphire. In its pure form, it is a colorless crystal of aluminum oxide, an extraordinarily hard, high melting point mineral that forms naturally on Earth only in specific metamorphic geological environments. On Earth, corundum in the form of gemstones is extraordinarily rare, found in specific geological deposits and valued at thousands of dollars per carat.
On HATP 7b, a gas giant approximately 1,000 light-years from Earth orbiting its host star in just 2.2 days, corundum is not a rare gemstone. It is a common atmospheric condensate, the equivalent of water droplets in Earth's clouds, forming wherever the temperature and pressure conditions of the atmosphere cross the condensation threshold for aluminum oxide. And because HATP 7b is tidally locked, with a permanent day side and night side separated by a violent atmospheric circulation pattern, the corundum clouds that form on the night side and evening terminator are carried by high-altitude winds at speeds of thousands of kilometers per hour, drifting, thickening, and thinning as they are caught between the heating of the day side and the cooling of the night side. The Kepler Space Telescope detected dramatic variability in the optical brightness of HATP 7b's day side, not the smooth, predictable variation of reflected starlight from a static atmosphere, but an erratic, time-varying brightness change caused by the shifting of corundum cloud coverage as the high-altitude wind patterns change on timescales of days. When those corundum droplets grow large enough, they precipitate, they fall, not as water, as gemstone rain. Droplets of aluminum oxide crystals, potentially containing the same chromium and iron impurities that make rubies red and sapphires blue on Earth, falling through the upper atmosphere of a gas giant 1,000 light-years away on a wind-driven continental-scale weather pattern whose variability is detectable from Earth as a fluctuation in the total light reflected by the planet. HATP 7b does not merely rain gemstones as a poetic metaphor. It does so as a direct, observationally confirmed consequence of its atmospheric chemistry and its thermodynamic environment.
Number 4. OGLE 2005-BLG390-LB, the most isolated, most frozen, most desolate confirmed planet in the galaxy. There is a planet in the Milky Way whose surface conditions represent the extreme lower boundary of what a planet can be and still be called a planet, rather than a frozen chunk of interstellar debris. It is called OGLE 2005-BLG390-LB. Discovered in 2006 through gravitational microlensing, the bending of light from a background star as the planet and its host star pass in front of it, producing a characteristic brightening event that lasted just a few days and was never repeated, giving astronomers a single, unrepeatable observational window into its existence. The planet is approximately 5.5 times Earth's mass, a super-Earth, orbiting a red dwarf star at a distance of approximately 0.006 astronomical units, roughly equivalent to the main asteroid belt in our solar system. Around a star as dim as a red dwarf, this distance places it far outside any conceivable habitable zone. The surface temperature of OGLE 2005-BLG390-LB is estimated at approximately minus 220 degrees Celsius, colder than the surface of Pluto, colder than the moons of Neptune, cold enough that carbon dioxide freezes solid, cold enough that nitrogen and even argon may condense as surface frost under the right conditions. The planet is located approximately 21,500 light-years from Earth, near the galactic bulge, the crowded, star-dense central region of the Milky Way, yet, paradoxically, one of the most isolated environments a planet can exist in from a thermal perspective, because the red dwarf host star provides so little warmth that the planet is essentially heated only by its own residual internal heat leaking outward from its formation billions of years ago. That internal heat source is itself fading. OGLE 2005-BLG390-LB is a super-Earth drifting toward the absolute zero of its own geological death in a galaxy center system we can never visit and never observe again, on a surface so cold that the rocks themselves may be as rigid and brittle as glass, in an atmosphere so thin and so frozen that the concept of weather has no meaningful application. It is the loneliest confirmed world in the galaxy, known to exist, impossible to revisit, freezing in permanent silence. Number 3. Kepler 70b, the planet that orbits closer to its star than the star's own surface once did. The history of planetary systems is a story of almost constant violence, disruption, and transformation across billions of years. Most people think of planetary orbits as stable, permanent features of a solar system. The planets formed where they orbit, and there they remain.
The reality, as planetary science has established through decades of exoplanet discoveries, is far more dynamic and far more brutal. Planets migrate. They fall inward through gravitational interactions with the disk of gas and dust from which they formed. They are scattered outward by encounters with larger neighbors. And in the most extreme cases, they are consumed entirely by their host stars as those stars evolve and expand. Kepler-70b, if it survives, a question that is itself actively debated, orbits a subdwarf B star, the hot, exposed, helium-burning core left behind after a red giant star shed its outer envelope at a distance of approximately 0.006 astronomical units. To provide context for how extraordinarily close this is, Mercury, the innermost planet in our solar system, orbits the Sun at 0.39 astronomical units, 65 times further from its star than Kepler-70b is from its host. The orbital period of Kepler-70b is approximately 5.76 hours. It completes a full year in the time most humans spend working a single shift. At this distance, the planet orbits inside the volume that its host star formerly occupied when it was a red giant, the expanded stellar envelope that the star shed to become the subdwarf it is today. Kepler-70b did not form at this location. It couldn't have. The planet was originally much further from the star and migrated inward either before or during the star's red giant phase, surviving the engulfment event in some form, or in an alternative interpretation representing a remnant of the former red giant's core rather than a conventional planet at all. The surface temperature of Kepler-70b is estimated at approximately minus 7,000 Kelvin, hotter than the surface of our Sun, hot enough that the planet's surface is entirely molten and actively evaporating its rocky material, streaming off into space as a comet-like tail of vaporized mineral. Kepler-70b is a planet in the process of being erased, a world that survived one stellar death only to be slowly destroyed by what that death left behind. Number 2. TRES-2b, the darkest planet ever discovered, blacker than coal and absorbing 99% of all light that strikes it. The human mind, when imagining an alien planet, naturally defaults to color. Rocky planets are gray or red or tan like Mars. Gas giants are brown and beige and white like Jupiter. Ice giants are blue like Uranus and Neptune. Even the darkest natural materials familiar from everyday experience, charcoal, black paint, the darkest natural minerals reflect a few percent of the light that strikes them. The concept of a planet that is effectively invisible, reflecting almost no light whatsoever, seems like science fiction rather than astronomy. TRES-2b is not science fiction. It is a confirmed exoplanet approximately 750 light-years from Earth, a hot Jupiter, roughly the mass of our own Jupiter, orbiting its host star every 2.47 days at a distance of approximately 5 million kilometers. It was studied extensively by the Kepler Space Telescope, which measured not just the dimming of the host star during planetary transit, but also the tiny variation in total system brightness as the planet moved around to its day side, the reflected light from the planet itself, the secondary eclipse signal. What Kepler found was that TRES-2b reflects less than 1% of the starlight that strikes it. Its geometric albedo is approximately 0.0004, making it darker than coal, darker than black acrylic paint, darker than any naturally occurring material measured anywhere in the solar system. The cause of TRES-2b's extraordinary darkness is not fully understood, which makes it more rather than less remarkable. The leading hypotheses involve the presence of light-absorbing compounds in its atmosphere. Gaseous sodium, potassium, and titanium oxide have all been proposed as absorbers. But no single compound or combination of compounds identified in hot Jupiter atmospheres fully explains an albedo as low as what TRES-2b displays. Something in this planet's atmosphere absorbs light with an efficiency that exceeds any known atmospheric chemistry, leaving the planet as a near-perfect blackbody, a world that swallows starlight as efficiently as physics allows, orbiting close enough to its star that the absorbed energy keeps its atmosphere at over 1,000 degrees Celsius despite reflecting essentially none of the light that hits it. TRES-2b is visible only by the faint infrared glow of its own heat. In reflected light, it is, for all practical purposes, invisible. Number 1. J1407-b, the planet with a ring system so enormous it would appear 80 times larger than the full moon if it replaced Saturn. In 2012, astronomers analyzing photometric data from the Super-WASP survey, a network of telescopes designed to detect exoplanet transits, identified a series of transit events around a young sun-like star called J14070 in the constellation Centaurus, approximately 420 light-years from Earth. The transit events were unlike anything produced by a normal planetary transit. The star's brightness dimmed by up to 95% at peak, meaning something was blocking 95% of the star's light, an object with a cross-sectional area vastly larger than any planet. The dimming lasted for weeks, not hours, and showed a complex multi-ring structure of brightening and dimming events within the overall transit that suggested not a single solid body, but a system of concentric rings, each producing its own individual transit signature as the entire ring system swept across the face of the star. The analysis pointed to a single extraordinary conclusion. J1407-b, the planet, or brown dwarf responsible, possesses a ring system with a total diameter of approximately 120 million kilometers, roughly 200 times the diameter of Saturn's ring system. If Saturn's rings were replaced with J1407-b's ring system, scaled to our solar system, they would extend halfway to Earth and would appear in our night sky as a disk, approximately 80 times the apparent diameter of the full moon. A vast glowing structure dominating the sky, visible in full detail to the naked eye, dwarfing every other object in the heavens except the sun itself. The ring system of J1407-b is estimated to contain a mass comparable to Earth in total, distributed across dozens of individual ring structures separated by gaps, some of which appear to be cleared lanes where moons are actively forming or have already formed. The entire structure is young. J14070 is a pre-main sequence star estimated to be approximately 16 million years old, meaning J1407-b's ring system may be a snapshot of the early solar system analog process by which planetary ring systems form and eventually consolidate into moons. Saturn's current rings are a thin, fading remnant of a system that was once far more massive. J1407-b may be showing us what Saturn looked like in its youth, scaled up to a size that makes our entire concept of what a ring system can be seem laughably modest. It is a planet wrapped in a structure so enormous that the word ring no longer seems adequate to describe it. A disc-shaped architecture of rock and ice the size of an inner solar system, orbiting a star younger than some of Earth's mountain ranges. I'll be sharing more similar videos in the future, so subscribe to stay tuned.